Hello friends, welcome to the channel. Today we are going to deal with the topic atomic structure, which is common in both chemistry as well as physics. Now, first of all, we have the J.J. Thomson's model. Now, in the J.J. Thomson's model, first of all, the scientist J.J. Thomson discovered the electron. Now, another thing, it is also called as the plum pudding model, in which negative charge is equally distributed as plums in a pudding, while this whole part which you can see, the leftover part, this is the positive part of the plum, you can say, or it is also called as the watermelon model, in which these negative charge resembles the seeds, while this part, the leftover part, resembles the watermelon. Now the another one is Rutherford's alpha scattering model. First of all, in Rutherford's alpha scattering model, this is the basic diagram of an atom, in which this is the small positive area in the middle, that is the nucleus, and various orbits lying in which electrons revolve. Now, in the Rutherford's alpha scattering model, first of all, he suggested that all the positive charge and nearly all the mass is concentrated in a very small volume of the nucleus at the center of the atom, this part basically. Now, the electrons were supposed to move in circular orbits around the nucleus. Now, let us see, there are two equations basically used, which we have to remember as well. mv square by r is equal to kze square divided by r square. Now these resembles the force equations, like mv square by r, this is centripetal force formula, and kze square by r square, this is the formula of force in case of electric current which we study. Now the another equation is kinetic energy plus the potential energy is equivalent to minus kze square divided by 2r. Now kinetic energy plus potential energy together, that means it is equal to the total energy. That means the total energy is equal to minus of kze square by 2r. Now there were certain defects which were found in the Rutherford's alpha scattering model. First of all, let us see the two defects. Basically, first one is the regarding stability of atom. First one is regarding the stability of atom. The stability. Now see, stability of atom, an electron moving in a circular orbit around the nucleus is accelerating, and according to electromagnetic theory, it should therefore emit radiations continuously. That means it should lose energy. Now, but thereby radius should be decreasing continuously and the electron would spiral down into the nucleus. But this does not happen. First defect was this one regarding the stability, while the second one was the regarding explanation of line spectrum. Regarding the explanation of the line spectrum. Now, regarding the line spectrum, due to continuously changing radii of the circular orbits of the electron, the frequency of revolution of electron must be changing. As a result of electron will radiate radiations of all frequencies. That is, the spectrum in these waves will be continuous in nature. But experimentally, the atomic spectrum are line spectrum, not the continuous spectrum. Okay, experimentally it was found that the atomic spectrum are line spectrum. They were the line spectrum, not continuous spectrum. Okay, now we have the Bohr's model. Now in the Bohr's model, various equations are also very useful, but first of all, let us deal with the theory. Now what does the theory says? First of all, in the Bohr's model, now we have the Bohr's model. Now in the Bohr's model, there are three postulates of Bohr. First of all, an electron moves only in certain circular orbits called the stationary orbits. These were basically called as the stationary orbits. In stationary orbits, the electron does not emit radiation. Now, according to him, when the electron revolves in a stationary orbit, it does not emit radiation. First was this. The second one was, according to the Bohr, there is a definite energy associated with each stable orbit, and an atom radiates energy only when it makes a transition from one orbit to another. That means if an electron jumps from one orbit to another, then only it is going to make some loss in its energy. Now, suppose there is energy E2 and energy E1. Now, energy E2 is the higher energy. I would say the energy of higher orbit, while E1 is considered as the lower energy, or I would say the energy of the lower orbit. Now, as you know, E is equal to, the formula of energy is h nu. Energy, this one is Planck's constant, and nu is the frequency. Now, this can also be written as E2 minus E1 is equal to h nu, or we can find the formula of frequency also by this. Nu is equal to E2 minus E1 divided by the Planck's constant. Now we can find out now whether there is loss in energy or gain in energy, as if E2 minus E1 comes out to be negative, or E2 minus E1 comes out to be positive. Now see, if this comes out to be negative, then it is exothermic, while if E2 minus E1 is positive, then it is endothermic. Now let us move to the third postulate of Bohr, which we have, right? The third postulate of Bohr. Now what does the third postulate says? Now we have Bohr found that the magnitude of electron's angular momentum is quantized, and this magnitude of angular momentum must be the integral multiple of h upon 2 pi. As we write, mvr is equals to nh upon 2 pi. It is quantized means that it is integral multiple of h upon 2 pi. That means n is any integer, right? Like we can say angular momentum c. Angular momentum that is also represented by capital L. This can be written as mvr. Now I'm writing v and rn because velocity of the nth orbit and radius also of nth orbit will be equivalent to nh upon 2 pi, integral multiple of h upon 2 pi. That means this n is an integer. This can have any value, right? This is the angular momentum, which is quantized. Now, let me name this equation to be equation 1, and one equation which we wrote previously, mv square by r is equivalent to kze square divided by r square. This can be equation 2. Now from equation 1 and 2, what I can write is the formula of radius. Now, if the value of n becomes equal to 1 and z becomes equal to 1, now this is the orbit and z is the atomic number. See, if the value of n becomes equal to 1 and z also becomes equal to 1, then the formula of radius will be equal to 0.529 angstrom. Now, let me also tell you the general formula of radius, which will be very helpful ahead. That is, radius in nth orbit can be written as equals to 0.529 n square by z angstrom. This value is in angstrom, right? 0.529 n square by z. Now we can write the formula similarly for velocity, that is 2.19 into 10 to the power 6 meter per second when the value of n is equal to 1 and also the value of z is equal to 1. Now let me also write the formula, the general formula of velocity. The general formula of radius was this one. The general formula of velocity is this. Velocity in nth orbit is equivalent to 2.19 into 10 to the power 6 z by n meter per second. Now similarly, let me tell you the formula of energy as well. Now see, as we know, the formula of kinetic energy is equals to half mv square. That means from here, energy is directly proportional to square of velocity. So what I can write from here is energy in nth orbit can be written as minus 13.6 z square by n square electron volt. Now see, I have done z square by n square. As you can see in the general formula of velocity, there was z by n. Similarly, in the general formula of energy, there is z square by n square. Now, one last thing which I will tell you for this video is the definition of ground state. Now see, ground state is commonly referred to as n is equal to 1. Right? See, ground state can be written as the lowest energy state. The lowest energy state of an atom or ion. Okay. Now the rest of it we'll deal in the next class. Thank you.